In this problem, we're given the function f of x equals x squared plus 4 on the interval 2 to 6. We're asked to calculate the midpoint Riemann sum with n equals 4 subintervals, and then calculate the midpoint Riemann sum with n equals 8 subintervals. Okay, so first thing we need to look at is the graph of this thing. So this is a parabola that's been shifted up 4. So to get an idea of what this looks like on the interval 2 to 6, let's draw it out. Okay, so it's been shifted up 4, so we'll say right here, and okay, so that's not completely accurate in terms of how fast this graph is going up, but it will give us a better visual representation. Okay, so we are looking at the interval from 2 to 6. Okay, so given that we have n equals 4 subintervals, we take the interval for letter A, we take the interval from 6 to 2, or 6 minus 2, and divide by the number of subintervals. So that's going to end up being 4 over 4, or 1. That tells us that each one of the subintervals is going to be 1 unit long. Okay, so what we're doing when we take the Riemann sum with midpoint is we're looking at each one of these subintervals, which is, it looks like since they're 1 unit long, it's going to be from 2 to 3, from 3 to 4, 4 to 5, and from 5 to 6. And we calculate where the midpoint is on that. So what is the midpoint between 2 and 3? Well, that little midpoint, I'll put a little tick mark there. That little midpoint is 2.5. So that's x equals 2.5. And then the next one is 3.5, 4.5, and 5.5. Okay, I'm not going to write all those out, but I'll write the last one at 5.5. Okay, so that's where we're going to calculate the function value when we're using the Riemann sum. Okay, so our answer is going to be the sum with 4 subintervals, and this is, let's go ahead and say midpoint sum with 4 subintervals, okay, is equal to, okay, for each one of these little rectangles, let me give you a little visual here. We're going to go up to the function at that midpoint and create a rectangle. Okay, so the left part of that is going to go above, and the right part of that is a little bit below. Okay, and the same here. Looks like we got a midpoint sum that goes here, so that part goes above, and that part goes below. Okay, above, below, you can see it a little more there, and on the last one you're going to be able to see it the best above the curve and below the curve. Okay, so the benefit of the midpoint sum over the left and the right sums is that it kind of usually evens out if you have a monotonically increasing or decreasing function. In other words, it's not going all over the place. If it's just going up like a parabola is in this problem, then some of your rectangles will be above and part of your rectangle will be below, and they kind of average out to be pretty close to the correct answer. All right, so we're going to figure out the area of each one of these rectangles. Okay, so in order to figure out the area of each one of these rectangles, we know this length, right? Each one of these lengths is 1. Okay, so each one of these rectangles is going to be multiplied by 1, and the height comes from the function value at that midpoint. Okay, so it's going to be 1 times f of, where's the first midpoint? 2.5, plus 1 times f of 3.5, plus 1 times f of 4.5, plus 1 times f of 5.5. Okay, now to figure out those, you can plug those into your calculator. I've got them in my graph. Okay, so I went and I plugged them into y equals and x squared plus 4, and make sure you change your window to ask. So hit second window and change it to ask, and then hit second graph, and it brings up a table, and you'll see I have all these values down there. Okay, so that ends up being, that's equal to 10.25. Remember, it's multiplied by 1, so the value here is multiplied by 1, so that doesn't change it, plus 16.25, plus 24.25, plus 34.25, And if you add all those up, you will get 85. Okay, so the midpoint sum with 4 subintervals is 85. All right, now let's do the same thing, except this time we're going to have 8 subintervals. So this is going to be a little bit longer of a problem. Okay, so we still have our graph here. Let's draw that again. Okay, we'll say here is 1, 2, 3, 4, 5, 6. Not exact, doesn't need to be perfect. Okay, so we're still going from 2 to 6. Okay, but this time, how many subintervals do we have? Well, it's 8, so we're still going to do 6 minus 2, but this time divide by the number of subintervals, which is 8. That's 4 over 8. That's equal to 1/2. So each one of these subintervals is going to be 1/2 units long. That means that we're going to go from, starting at 2 to 2.5, 3 to 3.5. Oops, I missed one. My mistake. Let's write it below then. 2.5 to 3, then 3 to 3.5, and 3.5 to 4, 4.5 to 5, and then 5.5 to 6. Okay, so those are our intervals. There are subintervals, but remember we're taking the midpoint of these subintervals, the midpoint. Okay, so when we're taking the midpoint of these subintervals, we need to figure out, okay, what's the midpoint between 2 and 2.5? And if there's ever any confusion, if you can't just see it right off the bat, as you probably can with this, halfway between 2 and 2.5 is 2.25. But if you can't, you can just add those up and divide by 2. Add them up, you get 4.5. Divide by 2, you get 2.25. Okay, so we've got our values that we're going to be using for the midpoint are going to be, let's say x of 0 is equal to 2.25. That's the middle of 2 and 2.5. X of 1 is equal to the middle of these two, which is 2.75. X sub 2 is going to be 3.25. That's the middle of these two. And you can see the pattern now. So x sub 3 is 3.75. X sub 4 is equal to 4.25. X sub 5 is equal to 4.75. X sub 6 is equal to 5.25. And x sub 7 is equal to 5.75. Okay, and that last one is the in between 5.5 and 6. Okay, so the difference between this one and the last one, well, there's a few differences, but one difference is that there's eight values that we're going to be plugging into the function because there's 8 subintervals. But also each one of our subintervals is no longer 1 unit long. In our last problem, they were 1 unit long. So they went from 2 to 3, 3 to 4, 4 to 5, 5 to 6. This one is going from 2 to 2.5, 2.5 to 3. So each one of them are 1/2 units long. So when we go to write our answer, we're going to have to multiply each one of the function values by 1/2 instead of 1 like we did last time. Okay, so here's our midpoint Riemann sum with 8 subintervals. Okay, so that's going to be equal to 1/2 times f of 2.25 plus 1/2 times f of 2.75 plus 1/2 of f times f of 3.25. I don't know why I put a parentheses there. Dot, 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 plus 1/2 times f of, what's our last one? 5.75. Okay, now you can take the half out front. So put the half, each one of them have a half, so you can take the half out front and just do f of 2.25 plus f of 2.75 plus dot, 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 plus f of 5.75. Okay, so that's what we're going to use to figure out the midpoint with 8 subintervals. Okay, so let me help a little. Okay, so let's type those in. Here's another way of doing it besides, last time I used the graph. In my videos I usually show both ways. Okay, so this is the way I'm going to do it this time. First, 1 divided by 2. And then I'm going to use, since I already have it typed in, y equals. So 1/2, and I can go to vars, move over to y vars, and hit enter on y1 because that's where I typed in the function, and then open parentheses and type in your first value, 2.25. Okay, and then I'm just going to do this over and over and over again for each one of the values. And you can skip ahead of this if you want till the end. It's going to take me a second. Okay, I've got them all typed in. I'm going to close parentheses again because I have a half that's sitting out front. And there we get a value. Then it should be pretty close to your first value. This time we get 85.25 instead of just 85. So it's probably a slightly more accurate representation of the area under that curve.